Let's differentiate these two questions from first principles. There's a formula we use for that. So the formula is f prime of x equals limits of f of x plus h minus f of x all over h as h approaches 0. So what you just have to do is to go and find the value of f of x plus h, because f of x is always given to you. So for question number 1, we find f of x plus h. We already know f of x, so f of x plus h simply means that wherever you see x squared, or wherever you see x, you fix in x plus h. So in this case, here is x, so we have x plus h squared. F of x was originally given, which is equal to x squared. So since we already have f of x plus h, we just fix it here. So f of x, f prime of x equals limits f of x plus h is x plus h squared minus f of x, which is x squared, all divided by h as h approaches 0. Now we have to expand the brackets over here. So in expanding the brackets, we have x squared plus 2xh plus h squared minus x squared, all divided by h as h approaches 0. Can we cancel out anything here? Yes, x squared can go out with negative x squared. So we are going to have limits of 2xh plus h squared, all on h as h approaches 0. Now we can factorize h out. So we can have limits of h into brackets 2x plus h, all on h as h approaches 0. So this h can cancel out with this one. So we are going to have limits of 2x plus h as h approaches 0. Now there's nothing we can do again, or there's no further we can go again. So we just fix h equals 0. So as you fix h equals 0 here, you don't write the limit and as h approaches 0. So this will be equal to 2x. What it means is that f prime of x is equal to 2x. So the answer for the differentiation of f of x equal x squared from first principles is 2x. This is the answer. Let's try the second question. So the second question, let me come this way. Okay, so for the second question, we have f of x to be equal to 3x plus 2. I said we always have to go and find f of x plus h. What it means is that f of x plus h, what it means is that wherever you see x here, you fix x plus h there. So you have x plus h plus 2. And this is going to be 3x plus 3h plus 2. Now we go back to the formula. From the formula, we have f prime of x to be equal to limit of f of x plus h minus f of x all over h as h approaches 0. So we fix f of x plus h there. We know that is, you repeat the limit again to be 3x plus 3h plus 2, all divided by h as h approaches 0. So what we've written here is for f of x plus h, but then minus f of x, which is 3x plus 2. We now have to expand the brackets here. So we can rewrite limits of 3x plus 3h plus 2 minus 3x minus 2 all over h as h approaches 0. So over here, this 3x can go away with this negative 3x. The same for this 2. So we are going to have limit as h approaches 0 of 3x divided by h, which is going to be equal to limit as h approaches 0 of 3. Now we have to fix in h equals 0, but there's no h in the first place. What it means is that the answer is 3. So differentiation from first principles of 3x plus 2 gives us 3. Now, if you want to use the formula, this is what you do. But then there's a general formula for the differentiation of functions, where if you have f of x to be equal to x exponent n, then f prime of x, which is the same as dy dx, will be equal to, you multiply the exponents by the original question or the original given function, they reduce the exponent by 1. So if we use the same thing here in the case of number 1, then we have, in the case of number 1, then we have from f of x equal x squared, we have f prime of x to be equal to, you multiply the exponent, which is 2 in this case, by the given function, then reduce the exponent by 1. This will give 2x, 2 minus 1 is 1. What it means is that f prime of x gives 2x, which is exactly what we had here. And in the case of this question too, we have f of x to be equal to 3x plus 2. This can be rewritten as 3x plus 2x exponent 0, because x exponent 0 is 1. 1 times 2 still gives 2. So if you differentiate this f prime of x, you have this x has exponent of 1, right? Times 3x, then 1 minus 1, then plus this exponent is 0, then 2x exponent 0 minus 1. So we are going to have 3, just 3 here, because it will be 3x exponent 0 plus 0 times all this gives 0. So the final answer is going to be 3, f prime of x, which is also what we had here. So this is a much easier way of proving that the answer you've had is correct. Thank you very much.